Welcome back to Sleepless Mysteries. On July 1st, 2025, astronomers spotted a faint traveler slipping into our solar system, a green-tinged body from another star, cataloged as 3I Atlas. At first, it seemed like a comet, dust, ice, fragments shedding as it warmed under the sun. But as data came in, one question began to rise louder than the rest. What happens when a visitor like this brushes too close to our star? Could the alien chemistry of 3I Atlas do more than glow in the night sky? Could it even stir the sun itself into a new era of storms? The sun is not still. Beneath its calm golden glow, plasma churns and magnetic fields twist, sometimes erupting outward in violent flares and coronal mass ejections. These storms can knock out satellites, darken power grids, and ripple across the Earth's magnetic shield. They come in cycles, familiar, measured. Yet history tells us the sun is capable of surprises. The Carrington event of 1859 unleashed auroras across the world and fires in telegraph wires. What if something from beyond, something not of this system, nudged the sun into chaos once more? 3I Atlas is not made of ordinary stuff. Its gases shine with cyanides, nickel, and organics that don't belong to our neighborhood. As it outgasses, its tail spills dust and ionized particles into the solar wind. Normally, comets leave only faint ripples. But an interstellar body carries chemistry shaped by another sun, another environment. Could its encounter add turbulence to the delicate fields surrounding our star? Could its trail become the seed of storms larger than those we have known? It sounds impossible, yet the cosmos is built on impossible things. Scientists still cannot fully explain why Oumuamua accelerated in 2017, or why Borisov shed water in such abundance in 2019. Now Atlas arrives as another anomaly, its orbit bending strangely, its glow shifting unexpectedly. 3 visitors, 3 riddles, each a reminder that the universe is far older and far stranger than we assume. If an alien comet can defy science in its chemistry, why could it not also touch the rhythms of a star? Ancient peoples looked at comets and feared exactly this. In China, broom stars were said to sweep the heavens clean, bringing storms and upheaval. In Babylon, fiery objects were linked to the anger of gods, capable of shaking the earth and sky alike. Even in Europe, chroniclers wrote of comets that set the heavens aflame before great storms followed. Were they exaggerations, or did they sense a truth science is only now beginning to glimpse? You don't need to see the comet to feel its presence. Just let these words guide you. Close your eyes if you wish. Picture the sun, vast and burning, its surface alive with arcs of fire. Picture an emerald-hued traveler drifting near, its tail shedding alien dust into the solar wind. Then picture the sun answering, its fields stirred, its storms ignited, its light suddenly less stable. Imagine the sky alive, Earth caught in the ripple of a star awakened. Before we begin, if you haven't already, subscribe to Sleepless Mysteries, so these quiet journeys into the unknown will always find you. Tap the like button if stories like this spark your imagination. And if you're still awake, share in the comments where in the world you are listening from and what time it is right now. Now, let the noise fade. Tonight we follow a comet from another star and ask, could its arrival ignite our sun into a new era of storms? 3I Atlas. Could it ignite the sun into a new solar storm era? From the moment astronomers first caught sight of 3I Atlas, the whispers began. Not just that it was an interstellar visitor like Oumuamua, not just that its trajectory made no sense, but that it seemed to carry with it a strange brightness, one that grew and pulsed in ways that didn't match ordinary comet behavior. And with each surge of unnatural light, a darker question emerged. Could its arrival somehow disturb the sun itself? It sounds unthinkable, almost apocalyptic, but as telescopes tracked its outbursts, more voices within the scientific community admitted what had once been dismissed outright. What if a body like this could trigger the sun into a stormy new era? And to understand the fear, you have to look back at history. Our sun has always cycled between calm and fury. Every 11 years or so, its magnetic fields twist and knot, birthing sunspots, solar flares, and coronal mass ejections that can tear across space. But sometimes something pushes those cycles into chaos. In 1859, the Carrington event released a storm so violent it set telegraph lines on fire and painted auroras across the skies of Cuba. Now imagine that multiplied by 10, 100, or even more. An age where the sun lashes out again and again with storms that would blanket Earth and Mars alike in radiation. This is the nightmare scenario tied to 3I Atlas, that its volatile chemistry and its strange fragmentation could act as a spark, pushing the sun into a phase humanity is not prepared for. But how could a comet-like body ignite the sun? The idea sounds fantastical, yet there are mechanisms worth considering. When a body rich in volatiles, carbon dioxide, nitrogen, hydrogen compounds, strays too close, it can inject raw material into the solar atmosphere. In ordinary cases, comets falling toward the sun evaporate harmlessly. But 3I Atlas is no ordinary body. It is larger, more elongated, and riddled with fractures that leak gas in violent outbursts. If it were to break apart near the sun, it could release a vast cloud of debris, enough to interact with the solar wind itself. Some plasma physicists speculate that such an injection of energy and material could destabilize localized magnetic fields, kicking off chain reactions far larger than any single flare. The sun, already restless, could be nudged into chaos. The unsettling part is how much of 3 Atlas defies natural expectations. Observers report it has brightened by magnitudes far beyond prediction, glowing with a green spectral line linked to diatomic carbon, a compound that gives it a ghostly, unnatural light. And as it sheds fragments, each piece seems to echo the parent body's activity, glowing, releasing, multiplying. If the swarm drifts closer to the sun, each fragment could carry its own explosive potential. Instead of one visitor, the star could suddenly be facing a cloud of interstellar debris, an impact event on a stellar scale. Skeptics argue the sun is far too massive, far too stable for a cometary body to make a difference. After all, the sun has consumed objects many times larger without blinking. But others counter that it's not about size, it's about timing and chemistry. A system on the edge of a magnetic cycle can be tipped by a relatively small push. Think of a fault line, stable for centuries until a single tremor cascades into catastrophe. Could 3 Atlas be that tremor for the sun? If such a solar storm era began, the effects would stretch far beyond astronomy. On Earth, satellites would fry, communication systems would fall silent, and power grids could collapse. Air travel would become dangerous as radiation flooded high altitudes, and astronauts aboard the ISS or any future Mars missions would be exposed to lethal doses. Mars itself, with its weak magnetic field, would suffer even more. Dust storms could be triggered by sudden heating, and any hope of sustaining future colonies would be thrown into jeopardy. And all of this could stem from an object no larger than a city, a frozen wanderer from another star system. What makes this mystery more haunting is how it ties into ancient warnings. Civilizations across the world recorded fears of a green torch in the heavens, or of double suns burning in the sky. Some described eras where the heavens raged with storms, burning crops and blackening skies. Could they have witnessed a fragmenting interstellar body before, one that stirred the sun into fury? The parallels are eerie, and they whisper that maybe humanity has seen this pattern before, just not in an age of satellites and fragile technology. For now, astronomers watch closely. Telescopes sweep across the sky each night, searching for new fragments, new outbursts, any hint of a trajectory that could bring the object closer to the solar furnace. Each report of a sudden brightening fuels speculation. Each shift in the coma's shape reignites debate. Official statements remain calm. There is no evidence yet that 3 Atlas poses a direct risk to the sun. But behind the scenes, the models keep running, the possibilities keep widening, and the uneasy truth remains. We don't fully understand what we're watching. And that perhaps is the real terror. It is not that 3I Atlas will ignite the sun, it is that we don't know if it could. We are peering at an interstellar messenger carrying chemistry and physics not native to our system, playing by rules we haven't fully learned. If it fragments further, if it drifts closer, if its debris swarms interact with solar plasma in ways we haven't seen before, we may find ourselves witnessing something our ancestors only hinted at in myth, the awakening of the sun into a stormy, unpredictable era. An age where every sunrise carries the weight of uncertainty and every flare could be the beginning of a new cycle of fire. Why scientists fear 3I Atlas is splitting into thousands of pieces. When astronomers train their telescopes on 3I Atlas, the interstellar visitor that has captured the imagination and fear of so many, one of the most disturbing trends they've noticed is its tendency to fracture. It doesn't behave like a stable comet or asteroid gliding on a predictable path. Instead, it erupts with violent outbursts, shedding material in a way that suggests not just gradual erosion, but wholesale fragmentation. And and with each passing week, evidence mounts that this visitor may not remain a singular body for long. Instead, it might be on the verge of multiplying into thousands of fragments, each one carrying its own risks, its own mysteries, and its own potential to alter the balance of our solar system. At first, astronomers believed the brightening of Three-Eyed Atlas was simply the result of typical outgassing, the way icy bodies vent when they approach a star. Carbon dioxide, nitrogen, and water vapor boil off, carrying dust and forming a glowing tail. But what has been seen here goes far beyond normal. Brightness has surged in fits and starts, sometimes doubling in intensity overnight, as if massive portions of its crust are breaking away all at once. This is not just venting, it's violent disintegration. The fear is not only that Three-Eyed Atlas is breaking, but that it is doing so in ways that defy known physics. Most comets crumble into a handful of large fragments before fading into obscurity. But telescopic images reveal swarms of tiny bodies clustering around the main object, like shards orbiting a central core. Some astronomers describe it as a satellite cloud, dozens, perhaps hundreds, of companion fragments trailing and drifting in loose formation. If this trend continues, the number could multiply into the thousands, creating not just one threat to monitor, but a fragmented army of interstellar debris. Why is this so concerning? Because each fragment carries its own trajectory, its own unpredictable orbit. The more pieces, the greater the chance that some may stray dangerously close to Mars, Earth, or even the Sun. What was once a single object with a chartable course becomes a swarm of smaller bodies scattering across space. It is like trying to predict the path of one stone thrown into a pond, only to discover the stone has shattered midair into 1,000 pebbles, each creating ripples of its own. Chaos replaces certainty. There is also the problem of energy. When a body splits apart, it doesn't do so quietly. Energy is released in the form of jets, flares, and shock waves of dust. Observations of Three-Eyed Atlas show sudden outbursts of light, each suggesting a fracture event. Some of these flares are so powerful that they have outshone the predictions of standard models, baffling researchers. If fragments continue to erupt in this way, each one could become its own source of instability, potentially colliding with others, releasing cascades of dust and gas, and forming a deadly cosmic cloud. For Mars, which lies perilously close to the projected path of Three-Eyed Atlas, this is especially worrying. A single intact object might have missed the planet entirely, passing by without harm. But a fragmented swarm increases the odds that some portion will intersect Mars' orbit. Even tiny shards could wreak havoc. With its thin atmosphere and weak magnetic field, Mars is vulnerable to even modest impacts. Dust storms, triggered by falling debris, could blanket the planet for years. And larger fragments could gouge its surface, leaving scars that change not just the land, but the very potential for future colonization. The risks extend beyond Mars. Earth, though safer by distance, is not immune to the long-term consequences of fragmentation. A swarm of interstellar debris could scatter across the inner solar system, creating a new class of meteors, each unpredictable and fast-moving. Unlike ordinary meteoroids, these would not be native to our system. Their chemistry, their density, their very structure would be alien. Some could burn up in the atmosphere, painting strange green streaks across the night sky. Others might survive to the ground, carrying materials unknown to our planet. Still others could strike satellites, space stations, or even spacecraft en route to Mars, jeopardizing humanity's expanding presence in space. This multiplication of threats is what makes scientists uneasy. A single interstellar visitor is a rarity, something to observe, study, and marvel at. But a disintegrating one becomes a nightmare. Each fragment adds another layer of unpredictability, another equation that cannot be solved with certainty. And while official statements remain cautious, some researchers have begun using words like swarm, cluster, and fragmentscape to describe what is unfolding. There are historical precedents too, and they are not comforting. In 1994, the comet Shoemaker-Levy 9 broke apart into over 20 pieces before slamming into Jupiter, each fragment leaving a scar larger than Earth itself. That was a solar system comet, already fragile. Now imagine a body from beyond our star system, carrying unknown chemistry, splitting into not 20 pieces, but hundreds, thousands, or more. The scars it could leave, on Mars, on the sun's atmosphere, or even on human technology, would be on a scale we are unprepared to face. The mystery deepens when you consider why 3i Atlas is breaking apart so violently. Some argue its composition is unusually fragile, a loose conglomerate of dust and ice barely held together. Others suspect something stranger, that internal heating, perhaps from radioactive isotopes or alien chemistry, is tearing it apart from the inside. There are even those who whisper that its behavior resembles artificial disassembly, like a structure meant to release pieces rather than remain whole. While mainstream science does not endorse this idea, the whispers persist because nothing about 3i Atlas has behaved as expected. Another unsettling factor is how the fragments seem to mimic the parent body's strange green glow. Normally, when a comet splits, its fragments dim rapidly, fading into obscurity. But here, many of the pieces continue to shine, as though carrying the same volatile chemistry as the core. This suggests that even the tiniest shards could remain active, venting gases, brightening unpredictably and acting as miniature versions of the original. 1,000 smaller comets could be born from the body of one, each trailing dust, each glowing with alien light. The implications for astronomy are profound. If interstellar visitors commonly fragment in this way, then the universe may be filled not with singular wanderers but with swarms, clouds of alien material drifting between stars, scattering seeds of chemistry wherever they pass. This ties into theories of panspermia, the idea that life may spread via cosmic debris. But alongside that hopeful vision comes the darker one, that such swarms could also destabilize planetary systems, trigger solar storms, or rain destruction on unsuspecting worlds. For now, telescopes continue their vigil. Each new observation of 3i Atlas adds to the story, but also raises more questions. Will it hold together until it passes Mars? Or will it shatter into a cascade of shards, turning one mystery into 1,000 smaller ones? Will these pieces drift harmlessly into the void, or will they scatter across the inner solar system, leaving us to track each one for years to come? The truth is that no one knows. That is why scientists fear its splitting, not because they can predict exactly what will happen, but because fragmentation multiplies the unknown. A singular visitor is strange but manageable. 1,000 shards, glowing, unpredictable, and alien. That is something far more terrifying. And somewhere in the night sky, as the object brightens and fractures again, we are left to wonder if we are witnessing the unraveling of a single visitor, or the birth of a cosmic swarm that will haunt our sky for generations. What if 3i Atlas fragments create a meteor storm across the solar system? When 3i Atlas first streaked into our solar system, most scientists expected to witness another fleeting interstellar visitor. A comet-like body would brighten, shed gas and dust, and then vanish back into the void, leaving little more than data points in its wake. But as telescopes watched its behavior more closely, a more disturbing possibility began to take shape. This object wasn't stable. It was splintering, bleeding fragments into space, multiplying into pieces too numerous to count. And with that realization came an unnerving question. What happens if these fragments don't simply drift away, but instead cascade through the solar system, unleashing a meteor storm unlike anything humanity has ever seen? To understand the scale of this possibility, you have to picture the mechanics of fragmentation. When a cometary body breaks apart, it doesn't simply vanish into dust. Each fragment takes on its own orbit, each one nudged slightly differently by the forces that ripped it from the parent. Gravity from nearby planets, solar wind pressure, and radiation all act on these shards, spreading them into long, trailing streams. Over time, these fragments can fan out into vast debris fields, stretching millions of kilometers across. Earth has seen this process before. Meteor showers like the Perseids and Leonids are the after effects of comets disintegrating. But what makes 3i Atlas different and infinitely more troubling is its sheer size, brightness, and alien origin. If it shatters into thousands of pieces, those fragments could spread across planetary orbits, creating multiple overlapping meteor streams that persist for centuries. The most immediate concern is Mars. Already in the crosshairs of 3i Atlas's projected path, the red planet could find itself facing not one impactor, but a swarm. Even if only a fraction of the fragments intersect Mars's orbit, the results could be catastrophic. Picture the thin Martian atmosphere pummeled by debris day after day, igniting the sky in streaks of fire, each impact lifting colossal plumes of dust. Mars is already prone to planet-wide dust storms that last for months. A sustained meteor storm could trigger a cascade effect, choking the planet's skies for decades. For scientists and engineers dreaming of colonization, this could mean a Mars rendered uninhabitable for generations, not because of its natural environment, but because of an interstellar visitor gone to pieces. But Mars is not the only target. Earth, too, could be swept into these fragment trails. At first, it might look like an unusually spectacular meteor shower, green streaks cutting across the sky, brighter and stranger than anything before. People would watch in awe, unaware of the dangers hidden within, because these wouldn't be ordinary meteors. Their chemistry is foreign, their density unknown, their volatility unpredictable. Some could explode in the upper atmosphere like the Tunguska event of 1908, flattening forests and shaking cities with shockwaves. Others might survive to impact the ground, delivering alien compounds or carving craters in populated regions. Satellites, space stations, and interplanetary probes would become targets, each fragment a bullet traveling at tens of kilometers per second. In an era where humanity depends on space-based infrastructure, even a handful of impacts could unravel communications, navigation, and global power systems. Beyond Earth and Mars, the fragments could rain down across the solar system in unpredictable ways. Venus, with its dense atmosphere, might glow with alien fireballs, lighting up its perpetual clouds. Jupiter and Saturn, with their immense gravity, could sweep up many fragments, but not without consequence. Impacts like those seen with Shoemaker-Levy 9 in 1994 could scar their atmospheres with massive bruises, visible even from Earth. The moons of the gas giants Europa and Enceladus Titan could be struck as well, possibly contaminating their hidden oceans with new chemical elements. In this sense, a storm of fragments might not only bring destruction, but also deliver the seeds of panspermia, spreading the building blocks of life to multiple worlds at once. This duality, the destructive storm and the seeding of life, is part of what makes the 3A Atlas mystery so haunting. If fragments rain across the solar system, are we witnessing a cosmic disaster, or the mechanism by which the universe plants the possibility of life on barren worlds? On Earth, many scientists believe comets once brought water and organic molecules that gave rise to biology. Could 3I Atlas, an interstellar wanderer, be attempting the same on a grander scale? To one planet, its fragments might spell death. To another, they might be the spark of Genesis. The physics of such a storm would be staggering. Thousands of objects, each tumbling at tens of kilometers per second, would create a shifting minefield of trajectories. Gravitational assists could sling fragments in unexpected directions. Some might be flung out of the solar system entirely, while others might settle into long-lived orbits, forming new belts of debris. Over centuries, these orbits would intersect with planetary paths again and again, creating recurring storms that future generations would have to endure. Humanity could find itself living under a new celestial hazard, with meteor seasons not tied to Earth's calendar, but to the remnants of an alien visitor. The cultural impact would be just as profound. Throughout history, humanity has looked to the skies and interpreted falling stars as omens. A storm of interstellar fragments, green, glowing, multiplying, would not only terrify but also inspire. Ancient prophecies of burning skies and torches from the heavens would be reinterpreted in eerie ways. Religions might see it as punishment or as a cosmic rebirth. Scientists would scramble to model the swarm, to predict which worlds were in danger and which might benefit. Governments would be forced to address not just planetary defense, but the possibility that alien materials could contaminate Earth in ways we cannot yet understand. And yet, perhaps the greatest fear is not what the fragments will do, but what we cannot predict about them. Every time a body like 3I Atlas splits, it violates expectations. Fragments that should fade instead brighten. Dust that should disperse instead clusters. Jets of gas burst from fissures that shouldn't exist. If these behaviors carry into the fragments, then a meteor storm born from 3I Atlas will not behave like any comet storm in human memory. It will be something new, something alien. And in that alienness lies danger. Imagine the night sky transform, not a gentle scattering of stars, but a relentless rain of light, streaking across the horizon night after night. Power grids flicker, satellites fall silent. On Mars, dust storms swirl endlessly, darkening the dream of colonization. On Earth, fireballs rattle cities and oceans alike, and above it all, telescopes track the swarm, counting fragments, mapping trails, but always falling behind. Because the object that came as one has now become thousands, each one a question mark hurtling through space. In the end, the storm scenario reminds us of how fragile our cosmic order really is. We like to think of the solar system as stable, predictable, clockwork in its orbits. But when a visitor from beyond intrudes, that order is shaken. A single body splitting into thousands can transform the skies of every planet, rewriting futures in fire and dust. If 3 Atlas continues to fracture, humanity may find itself living under the shadow of a storm that will not pass quickly, but linger for generations, reshaping our relationship with the cosmos forever. The awakening star, could 3I Atlas trigger the sun's hidden fury? For as long as humanity has looked to the skies, the sun has been our source of warmth, growth, and life itself. But it has also been feared, worshipped, and seen as a temperamental god capable of fury beyond imagination. Every civilization that ever gazed upward knew the sun was not always gentle. Periodically, it lashes out with storms of fire, flares that can engulf entire planets with radiation, and waves of plasma that ripple across the void. And now, with the arrival of 3I Atlas, astronomers find themselves asking a question that seems both apocalyptic and strangely plausible. Could this wandering interstellar object act as a trigger, pushing the sun into a phase of hidden fury, a solar awakening that reshapes the destiny of our world and others? The first clue lies in timing. The sun is currently entering the peak of one of its magnetic activity cycles. Every 11 years, its internal fields twist and knot, building to a maximum before unraveling again. These cycles dictate the intensity of solar storms, sunspots, and coronal mass ejections. During solar maximums, the sun is already restless, prone to bursts of energy that dwarf anything humanity can produce. And it is precisely during this sensitive moment that 3 Atlas has arrived, carrying its volatile chemistry and unpredictable fragmentation into the heart of the system. To some researchers, the coincidence feels more like design than accident. But how could a comet-like body possibly disturb something as massive and ancient as the sun? The question seems absurd at first. The sun has consumed planets, swallowed asteroids, and devoured countless comets without so much as a shiver. Yet the fear is not about size, it is about instability. When magnetic systems are already primed for eruption, even a modest disturbance can act like a spark on dry tinder. 3I Atlas, brightening violently and shedding volatile gases, could provide precisely that spark. If fragments plunge into the sun or graze its corona, they may inject streams of plasma and carbon compounds, destabilizing local fields and unleashing chain reactions across the stellar surface. This idea isn't pure speculation. Astronomers have observed sun-grazing comets before, icy bodies that skim the outer atmosphere of the sun. Some vanish silently, but others trigger flares and eruptions, as though their intrusion irritates the star into lashing out. Now imagine not a tiny local comet, but a massive, elongated alien body, unlike anything our system has seen before. Worse still, imagine it splitting into thousands of fragments, each with the potential to collide with the solar furnace. The result could be not just a flare, but a cascade, a domino effect of eruptions across the surface, birthing a storm era more violent than anything in recorded history. The consequences of such an awakening would be immediate and profound. A single massive coronal mass ejection could unleash trillions of tons of plasma into space, traveling at millions of kilometers per hour. If directed at Earth, it would slam into our magnetic field, compressing it, destabilizing it, and flooding the atmosphere with charged particles. Satellites would fail. Power grids could collapse. Auroras would shimmer over every latitude, even the tropics, as the skies burned green and red. The Carrington event of 1859 was a small taste of this fury, and it was enough to set telegraph wires ablaze. In our modern world, dependent on electronics, the impact could be catastrophic. Mars would face even harsher consequences. With only a faint magnetic field to shield it, the red planet could be bombarded directly by radiation. Any astronauts stationed there or on their way would be exposed to lethal doses within hours. The atmosphere, already thin, could be stripped further. Storms of dust could be triggered as sudden heating destabilized the surface. Colonization efforts might be delayed by decades, if not abandoned altogether. For a world humanity dreams of calling its second home, the fury of the sun could reduce it to a hostile wasteland once more. Some scientists also raise the possibility that repeated solar outbursts could alter planetary climates. Earth's weather systems are finely tuned to solar input. If the sun entered a hyperactive phase, even for a few years, the added energy could warp climate patterns, intensify storms, and disrupt agriculture. In a way, 3I Atlas might not just endanger technology, it might challenge the very stability of ecosystems that support human civilization. Yet there is another, stranger angle to the mystery. Ancient records describe visions of two suns or green torches lighting the heavens, followed by times of upheaval. Babylonian texts, Mayan stelae, even medieval chronicles speak of cosmic visitors coinciding with strange solar behavior, unusual auroras, scorching summers, and famines. Could those be echoes of a previous interstellar object, one that disturbed the sun in some way? If so, the arrival of 3 Atlas may not be the time our star has been awakened by a wanderer from the void. Even the object's eerie green glow has sparked speculation. Its spectral signature reveals strong carbon emissions, particularly diatomic carbon, which fluoresces in the emerald band of visible light. To astronomers, it's chemistry. To seers of old, it was the sign of an omen. The green flame in the sky is a motif found in prophecies across continents, often linked to storms, wars, or the burning of the heavens. Whether coincidence or warning, the parallels strike uneasily when paired with modern fears of solar storms. Of course, the official stance of most astronomers is caution, not panic. They emphasize that the sun is immense and resilient, and that while sun-grazing bodies can trigger localized effects, the odds of an interstellar object awakening a new solar era remain slim. But the truth behind their caution is the same truth that fuels the fear. We do not fully understand the interactions between foreign bodies and our star. We have observed too few events, studied too few examples, to know with certainty, and uncertainty is its own kind of terror. Imagine, then, the unfolding scenario. 3I Atlas continues to fracture, its swarm drifting closer to the solar furnace. One fragment plunges in, vaporizing instantly. A flare arcs out, another fragment follows, and another, each one compounding the disturbance. Soon the sun is roaring with activity, sunspots multiplying, plasma waves cresting across its surface. The skies of Earth light up with auroras that refuse to fade, while cities plunge into blackout after blackout. On Mars, dust storms rise as the thin air superheats. Across the system, planets feel the breath of a star stirred from slumber by an alien visitor. This is the nightmare hidden in the phrase awakening star. The sun does not need to explode, collapse, or transform to ruin our world. It simply needs to become angrier, stormier, less predictable. And if 3I Atlas plays even a small role in tipping it into such a phase, then this visitor from the void may be remembered not as a passing comet, but as the herald of a fiery age. In the end, we are left with more questions than answers. Could 3I Atlas truly influence the sun on such a scale? Or are we projecting fears onto a cosmic coincidence? Are the ancient prophecies of fiery skies echoes of real events or myths born from imagination? And most importantly, if the sun does awaken into a stormy new era, will humanity have the resilience to endure it? For now, the only certainty is this: the sun has always carried hidden fury within it. Whether 3I Atlas becomes the spark that awakens it is a mystery we may witness not in theory, but in fire. Fragments without number, the multiplication mystery of 3I Atlas. When the first reports of 3I Atlas arrived, astronomers described a singular object, elongated, green-glowing, tumbling through the void. It was supposed to be one body, one path to chart, one interstellar puzzle to study before it passed back into the black. Yet, as days turned to weeks, that assumption began to unravel. The visitor did not remain whole. It fractured, then fractured again and again. Outbursts of light were followed by the detection of secondary bodies trailing close behind. What had entered as a singular stranger was beginning to look like a multiplying presence, one that defied the comfort of simple classification. Scientists now face a sobering possibility. What if 3I Atlas does not break into a handful of pieces, but into thousands, fragments without number, each carrying the mystery of its origin and the danger of its unpredictability. This phenomenon has a precedent, but none so unsettling. Comets within our system often fragment when heated by the sun. Some disintegrate quietly, leaving faint trails of dust that seed meteor showers centuries later, but others erupt into swarms. Comet 73P Schwassmann-Wachmann, for instance, split into more than 60 identifiable pieces in 1995, scattering across the night sky like glowing beads. Shoemaker-Levy 9 broke into 20 fragments before colliding with Jupiter, each impact leaving an Earth-sized scar, yet both were native comets. Their behaviors, though violent, understood within the framework of solar system dynamics. 3I Atlas is different. It is not from here. It carries chemistry and structural properties alien to our sun, and its multiplication seems to exceed all normal scales. Observers now speak of secondary comae, tiny halos of gas and dust surrounding smaller fragments. These are not fading sparks, but miniature versions of the parent body, active and bright in their own right. For every fracture that occurs, more sub-objects appear, and they too begin to release volatile gases, glowing with the same eerie green light. It is as though 3I Atlas reproduces rather than merely shatters, creating a self-propagating swarm that challenges the very idea of what a comet is. Is it one object? Or is it a cluster, a hive, a phenomenon designed by physics, or by something else to multiply endlessly? The danger of such multiplication is not abstract. Each fragment follows its own slightly altered trajectory, tugged by gravity, nudged by outgassing jets, pushed by the solar wind. At first, the swarm clings together, a loose cloud around the parent body. But as time stretches on, the distances widen. 1,000 fragments could scatter across millions of kilometers, each one impossible to track with certainty. What began as a single predictable path becomes chaos, a debris field across the inner solar system. And chaos in space translates into danger for any planet, any spacecraft, any human venture into the void. Mars once again stands in the direct line of speculation. A single intact 3I Atlas might have posed little more than a spectacular flyby, but a fragmented swarm increases the probability of impact exponentially. Even tiny shards, no larger than a house, could release energy equivalent to nuclear detonations upon striking the Martian surface. The result could be craters, shockwaves, and the lofting of enough dust to veil the skies for years. For colonization projects, this would be ruinous. For planetary science, it would be transformative, a violent rewriting of Mars's geology before our eyes. Earth, though safer at its distance, is not exempt from the multiplication problem. A swarm of fragments increases the odds that some will wander into Earth's orbital neighborhood. Imagine a meteor shower that does not last for hours, but for months. Fireballs streaking nightly across the skies, some burning green, others exploding in the upper atmosphere like miniature Tunguska events. For satellites and spacecraft, the hazard is severe. For humanity on the ground, the psychological toll could be just as heavy. The sky itself would seem unstable, no longer the calm backdrop of stars, but a storm of alien debris. What troubles scientists most is that the multiplication defies expected decay. Normally, fragments from a breaking comet fade quickly. They are smaller, less volatile, and less capable of sustaining activity. Yet the shards of 3 Atlas appear to remain bright, their comae sustained as though each is carrying a core of rich volatiles. This suggests the body is riddled with such material throughout, a structure not of rock with a frozen crust, but perhaps a porous, crystalline matrix saturated with exotic compounds. If true, then every break simply exposes new surfaces to sunlight, creating more active bodies. The multiplication could continue until thousands, or even tens of thousands, of pieces swarm across the system. The question then arises, what is the true nature of 3 Atlas? Some argue it is simply a fragile interstellar comet, a loosely bound aggregate of dust and ice that was destined to fall apart. Others whisper of stranger possibilities. Could it be artificial? A probe or vessel designed to scatter into countless pieces, each with its own trajectory? The behavior is almost viral, self-replicating, spreading, persisting. While mainstream astronomy does not embrace such speculation, it is hard to ignore the parallels to engineered systems that rely on redundancy and multiplication. One piece may fail, but thousands ensure survival. The multiplication mystery also reopens questions of panspermia, the idea that life spreads through the universe via fragments of comets and asteroids. If 3I Atlas is scattering not just dust but complex organic molecules, then each shard could become a seed, carrying alien chemistry to planets and moons across the solar system. Some might burn in atmospheres, releasing exotic gases. Others might land intact, embedding themselves in soils, oceans, or icy crusts. Could this be how life travels the stars? Not in singular vessels, but in swarms of fragments, each carrying the potential to awaken new worlds? Ancient traditions offer eerie echoes of this idea. Prophecies speak of a star that multiplies, of fiery objects swarming across the skies, heralding times of change. Indigenous myths describe stone seeds that fell from the heavens, bringing both destruction and renewal. Medieval texts warn of green torches that would split into many, scattering their fire upon the earth. To those who recorded such visions, these were omens. To us, they may be records of past encounters with interstellar visitors that behaved much like 3I Atlas does now. What makes the multiplication mystery so difficult to confront is its unpredictability. A singular body can be modeled, its orbit calculated centuries into the future. A swarm of thousands cannot. Each fragment is a question mark, each trajectory a shifting probability. Astronomers attempt to track them, but telescopes can only cover so much sky. Some pieces vanish into the glare of the sun, others drift unseen into the outer dark. It is possible that years from now, fragments of 3I Atlas will still be turning up, impacting moons, striking planets, or blazing unexpectedly into Earth's atmosphere. The psychological effect of such uncertainty should not be underestimated. For the first time in human history, we are faced with the idea of an interstellar swarm, something alien, multiplying, spreading, and beyond our control. It is no longer just a comet, no longer just a curiosity for scientists. It is a presence, a phenomenon that could linger across our skies for decades. And perhaps that is the greatest mystery of all. Is 3I Atlas an accident of nature, a fragile body unraveling under the sun's heat? Or is it something more, a visitor whose true purpose is not to pass silently, but to multiply, to spread, to leave behind pieces of itself as it goes? Until we know, we can only watch as the numbers grow, as the singular becomes plural, as the night sky becomes littered with fragments without number. In its multiplication, 3 Atlas reminds us that the cosmos is not always neat, not always singular, not always predictable. Sometimes the universe sends us not one mystery, but thousands, and asks us to live beneath their shadow. What happens if a piece of 3I Atlas falls into the sun? The sun has swallowed countless objects over its lifetime. Comets, asteroids, and even dwarf planets have plunged into its furnace, dissolving in seconds. Most of these sacrifices pass unnoticed by all but the most dedicated solar watchers. Yet with 3I Atlas, an interstellar wanderer that has already baffled astronomers with its erratic brightening and multiplication into fragments, the possibility of a direct plunge into the sun carries a weight of fear and fascination. Because this time, the object is not local. Its chemistry is alien. Its behavior is unpredictable. And the question becomes, what if one of its pieces, or worse, several, falls directly into the solar fire? Could such an event unleash something far beyond what we've ever witnessed, stirring the sun into a fury that engulfs the entire solar system? At first glance, the logical answer seems simple. The sun is so massive, so powerful, that even a fragment the size of a mountain would be insignificant. A piece of 3I Atlas, no matter how large, would vaporize instantly upon contact with the solar corona. Its volatiles would disperse, its dust would vanish, and the event would be over in moments. But physics is rarely that tidy when systems are already unstable. The sun is not a calm, static ball of light. It is a roiling, seething furnace of plasma, crisscrossed with magnetic fields so tangled that even minor disturbances can trigger eruptions of unimaginable scale. And 3I Atlas has a way of delivering disturbances. When sun-grazing comets from our own solar system have fallen into the sun, they have sometimes been linked with sudden flares or coronal mass ejections. In 2011, a comet plunged into the solar atmosphere just as an eruption occurred, leading scientists to speculate that the event may have been triggered or enhanced by the intrusion. If small, ordinary comets can do this, what might a chemically exotic, fragmenting interstellar body provoke? The first concern is chemistry. 3 Atlas glows green, a signature of diatomic carbon and other volatile compounds uncommon in such abundance among local comets. Some spectra suggest nitrogen-rich compounds, carbon dioxide in unusual ratios, and even traces of metals rare in our system. If a fragment carrying such material slammed into the sun, it could inject these elements directly into the corona. There, at millions of degrees, they might catalyze plasma reactions we have not seen before. Localized instabilities in the magnetic field could be amplified, creating eruptions that ripple outward. A small fragment would not ignite the sun in the cinematic sense, but it could act like a spark in dry tinder, releasing energy far larger than itself. The second concern is numbers. 3 Atlas is fracturing into many pieces. One fragment might vanish quietly, but what if dozens plunge in succession? A hail of alien debris falling into the star over days or weeks. Each injection of material could push the solar system closer to chaos, layering instability upon instability. Imagine a sequence of solar flares, each larger than the last, until the sun is effectively storming without pause. Such a chain reaction could mark the beginning of a new era of solar hyperactivity, what some researchers call a solar storm epoch. The consequences of this would ripple outward almost immediately. For Earth, the danger lies in the electromagnetic fury. A major coronal mass ejection directed at our planet could compress our magnetosphere and send currents ripping through our power grids. Satellites would short out, GPS would fail, air travel would become hazardous. In 1859, the Carrington event did just this with only telegraphs at risk. In today's hyper-connected society, the fallout could mean a collapse of communications, navigation, and even food distribution chains. A world plunged into a sudden solar blackout might take years to recover. For Mars, the situation would be even worse. With only a vestigial magnetic field, the red planet offers little defense. Solar radiation from such an event could strip its atmosphere further, exposing its surface to lethal radiation levels. Any colonists stationed there would be forced underground if survival were possible at all. Dust storms, triggered by sudden heating, could blanket the planet for years, choking the dream of terraforming before it begins. Even beyond Earth and Mars, the outer planets would not escape. The magnetic fields of Jupiter and Saturn might deflect much of the radiation, but their moons, Europa, Ganymede, Titan, would be bathed in charged particles, altering their fragile environments. Spacecraft in transit, probes orbiting distant worlds, even the infrastructure we've placed in orbit around Earth, all of it could be at risk from the sun's wrath, awakened by a fragment that did not belong. The idea is unsettling enough from a scientific perspective, but when paired with ancient records, it becomes haunting. Myths from cultures across the world speak of the day the sun was fed, or when the torch fell into the fire and the heavens roared. Babylonian tablets describe a wandering star plunging into the solar disk, followed by scorching summers and famine. Mayan codices speak of 2 suns burning together before storms of fire consumed the land. Could these be poetic memories of past encounters with interstellar visitors? Could a previous fragmentary wanderer have collided with the sun, triggering an age of solar unrest remembered only as myth? If so, then 3I Atlas may not be the first to fall. It may simply be the latest. And if history is any guide, the consequences could be more than spectacle. They could reshape civilizations. Yet, not all implications are dark. Some scientists see in such an event the possibility of discovery. If alien chemistry enters the sun, we may observe plasma behaviors never before recorded, revealing new insights into both stellar physics and interstellar matter. Studying the spectral fingerprints of such an impact could teach us what lies beyond our system, what elements exist in the broader galaxy, and how interstellar wanderers carry them across the stars. For all its danger, a fragment's fall might also expand our knowledge in ways that no safe experiment could. Still, the risks outweigh the curiosity. What keeps astronomers awake at night is not simply the thought of one fragment falling, but of many. A cascade of impacts could be like a drumbeat, each strike echoing louder until the sun's fury is unavoidable. And the truth is, we cannot stop it. We can only watch, measure, and brace for what comes. Imagine the scene, a brightening in the sky as 3I Atlas continues to fracture. One fragment curves inward, grazing the corona, igniting a flare visible even from Earth. Hours later, another plunges deeper, sparking a coronal mass ejection that streaks toward the blue planet. Days later, a larger shard is swallowed whole, and the sun erupts in a chain of storms that engulf the system in waves of radiation. On Earth, the night sky glows with auroras even at the equator, while cities plunge into darkness as power grids collapse. On Mars, astronauts huddle in bunkers as dust storms rage overhead. The sun, fed by a visitor from beyond, rages in a way unseen in millennia. This is the haunting possibility behind the question: what happens if a piece of 3I Atlas falls into the sun? It may dissolve instantly, leaving no trace. Or it may trigger a cascade of fury, awakening a star already restless. And if that happens, the consequences will not be confined to the object itself. They will ripple across planets, across civilizations, across the very balance of the solar system. For now, astronomers monitor every flicker, every flare, every fragment's path. The sun watches too, waiting, and somewhere in that delicate balance between fire and void, the question remains unanswered. Will the fall of a fragment be nothing more than a spark, or the moment the sun remembers its hidden fury? Cosmic domino effect: how splitting fragments could spark solar chaos. When scientists first began observing 3I Atlas, they treated it as a singular, if strange, visitor from the stars. But as days passed and data flowed in, the story changed. The object brightened, then fractured. Fragments appeared, glowing with the same eerie green light as the parent body, each behaving almost like a miniature comet of its own. What began as one object soon became many, and with this multiplication came a realization. In space, chaos spreads like falling dominoes. A single fracture can lead to dozens. Dozens can become hundreds. And if those fragments interact with the sun at the wrong time, they could trigger something far larger than themselves. A chain reaction of solar chaos rippling across the solar system. To understand this cosmic domino effect, we need to consider how delicately balanced the sun's outer layers really are. The solar corona, the glowing atmosphere that stretches millions of kilometers into space, is held together by tangled magnetic fields. These fields build tension like springs wound too tight. When they snap, the sun erupts in flares and coronal mass ejections, sending waves of plasma hurtling outward at millions of kilometers per hour. Most of the time, these eruptions are part of a natural cycle tied to the sun's 11-year rhythm of activity. But what happens if an external disturbance hits the system when it is already on edge? Like a stone tossed into a pond, a fragment from 3I Atlas could ripple across the solar surface, disturbing localized magnetic knots and setting off eruptions far larger than the initial impact. Now multiply that by not one fragment, but hundreds. This is where the domino effect comes into play. A single fragment could disturb a small region of the sun, but if the object continues to fracture, its pieces may fall into the sun in waves, each one adding another spark. The first fragment weakens the system. The second pushes it further. By the third or fourth, eruptions are cascading, feeding one another, until the sun is storming uncontrollably. Scientists already worry about naturally occurring superflares, events thousands of times more powerful than normal solar eruptions. Could an alien body like 3I Atlas provide the trigger for such a superflare, not in theory, but in reality? The mechanics of fragmentation make this scenario all the more likely. 3I Atlas is not crumbling quietly. It is exploding into active pieces, each with its own jets and outbursts. These fragments are not inert rocks. They are volatile, venting gases and glowing with the strange carbon-rich chemistry that gives the parent body its green aura. As each fragment is exposed to sunlight, it becomes unstable. Some may be flung outward, others inward, their paths nudged unpredictably by outgassing and solar wind. The more fragments there are, the more unpredictable their collective behavior becomes. At some point, the swarm stops being one visitor and becomes a cloud, a storm of bodies whose probabilities cannot be tracked with precision. In that chaos, the likelihood that at least some fragments plunge toward the sun grows higher. And this is where the dominoes begin to fall. Picture one fragment entering the corona, vaporizing in seconds, but releasing a surge of carbon and dust into a magnetically tense region. The injection destabilizes local plasma, and a flare erupts. That flare releases shockwaves that ripple across the solar surface, loosening knots in distant fields. Hours later, another fragment falls in, adding fresh material to an already disturbed system. Another eruption follows, stronger this time, its coronal mass ejection blasting outward into space. Then comes a third, a fourth, until the sun itself seems to be chained into a frenzy of eruptions, each one bigger than the last. The consequences for the solar system would be immediate and devastating. For Earth, the cascade of solar storms could overwhelm our magnetic shield. One coronal mass ejection can cause auroras and damage satellites. Multiple in rapid succession could collapse power grids, disable communication networks, and plunge societies into blackouts. Unlike a single storm, which humanity might recover from in months, a chain of storms could stretch over years, striking again before recovery is possible. The global economy, reliant on digital systems and orbital infrastructure, would teeter on the edge of collapse. For Mars, with its thin atmosphere and weak magnetic field, the consequences would be even harsher. A domino effect of solar storms could strip what remains of its air, irradiating the surface with lethal levels of charged particles. Dust storms, triggered by sudden atmospheric heating, could blanket the planet for decades. Colonization projects would be halted indefinitely, not by the planet's nature, but by the sun's fury. Even the outer planets would feel the storm, their magnetospheres battered, their moons bathed in radiation that could alter their icy surfaces and subsurface oceans. Yet, the domino effect does not end with impacts on planets. It could also destabilize human activity in space. Satellites and space stations would be vulnerable to repeated strikes, their electronics fried by radiation. Spacecraft traveling between planets could find themselves caught in waves of plasma, their shielding inadequate. Even future missions to the Moon or Mars would have to contend with solar conditions too hazardous for safe travel. Humanity's steps into the cosmos could be stalled by storms we did not cause, but inadvertently provoked. There is also the long-term risk that such solar chaos could alter climate patterns on Earth. While solar storms primarily affect technology, sustained increases in solar radiation could subtly warm or destabilize the atmosphere, shifting weather patterns in ways we do not yet fully understand. Droughts, storms, or disrupted monsoons could follow, turning a cosmic event into a terrestrial crisis. What makes this scenario all the more unnerving are the echoes in ancient records. Cultures across the world spoke of eras when the sun burned without rest, when skies glowed red for months, when crops failed under searing summers and endless storms. Some described green torches in the heavens preceding these fiery ages, as though an alien visitor arrived, multiplied, and then fed the sun into chaos. Whether myth or memory, these accounts align eerily with what scientists now fear, that an interstellar object, multiplying into countless pieces, could disturb the sun enough to awaken its hidden fury. Of course, the official consensus remains cautious. Astronomers emphasize that the sun is vast, resilient, and unlikely to be thrown into chaos by fragments, however exotic. But behind that caution lies the unspoken truth. No one knows. We have no precedent for an interstellar swarm interacting with our star. We have no models that account for chemistry beyond our system, and we have no way to predict whether a cascade of impacts would simply fizzle or ignite a domino effect of solar storms. Imagine, then, the unfolding chain. The first fragment falls, a flare erupts. Days later, the second plunges in, triggering a coronal mass ejection that surges toward Earth. Satellites fail, power grids flicker. The third fragment follows, the sun now storming continuously. The fourth, the fifth, and the sixth add to the fury until the system is in chaos. On Earth, auroras blaze nightly across the skies, but beneath their beauty lies collapse. Silent phones, darkened cities, grounded aircraft, faltering hospitals. On Mars, colonists retreat underground as dust storms rise. Across the outer planets, probes fall silent one by one, their circuits fried. Humanity watches the dominoes fall, helpless, as an interstellar visitor unleashes consequences beyond calculation. This is the essence of the cosmic domino effect. It is not that 3I Atlas itself is large enough to change the sun. It is that its fragments, falling in succession, could cascade into instability, tipping a system already on edge. A single spark cannot burn a forest, but many sparks, falling one after another into dry tinder, can unleash a firestorm. And in this case, the forest is our star, the heart of our system, the fire upon which every life depends. The real terror lies not in certainty, but in uncertainty. Could a cascade of fragments truly provoke such chaos? Or would the sun, vast and unyielding, shrug it off as it has shrugged off so many smaller intrusions before? For now, no one can say. We can only watch as the fragments multiply, the swarm grows, and the dominoes line themselves up in the dark, waiting for the first to fall. Is 3I Atlas breaking apart or multiplying into a swarm? When 3I Atlas was first spotted drifting into our solar system, it appeared as a single elongated object, bright, green, and mysterious. Astronomers expected the usual story. A comet-like wanderer, shedding dust and gas as it drew closer to the sun, flaring with activity until it faded back into darkness. Yet almost immediately, something strange began to happen. The object did not simply brighten, it fractured, scattering visible fragments around itself. But these fragments did not die quickly, as ordinary comet shards do. They glowed, they vented, they seemed to act like miniature versions of the parent body. And that is where the unsettling question arises. Is 3I Atlas truly breaking apart, or is it multiplying, creating not fragments, but a swarm? In the natural order of things, comets break. They are fragile, icy conglomerates, more dust and gas than solid stone. When the heat of the sun reaches them, they crack under the stress. Some split into 2 or 3 pieces, trailing each other like ghostly companions. Others disintegrate entirely, fading into clouds of dust that eventually seed meteor showers on Earth. But 3I Atlas has refused to follow the script. Each time astronomers expected its fragments to fade, new ones appeared, some as bright as the original. It is as though every break gave birth to smaller comets, each glowing with the same green fire, each trailing its own faint halo. This is what has unsettled observers most. The fragments are not decaying, they are persisting. They are behaving less like broken rubble and more like reproductions. Some astronomers describe the effect as self-similar fracturing, where each new piece mirrors the parent, retaining its activity. But others whisper of something stranger. Could 3I Atlas be designed, by nature or by something else, to replicate? The implications of such a swarm are staggering. If 3 Atlas is multiplying, then the number of bodies to track increases exponentially. 1 visitor is a curiosity. 10 are a problem. 1,000 are a crisis. Each fragment would follow its own orbit, nudged by outgassing and solar wind into slightly different paths. Together, they would form not a single predictable trajectory, but a cloud, an interstellar hive crossing our system. Predicting their movements would be nearly impossible. Some might crash into Mars, others might skim the sun. A few could even wander into Earth's orbital path, unseen until they flare in the atmosphere. The night sky could transform into a canvas of streaking green fire, both beautiful and terrifying. Mars, already in danger from the main body's projected path, faces the highest risk. If even a fraction of the swarm intersects its orbit, the planet could be bombarded with impacts. Each collision would raise dust into its fragile atmosphere, fueling storms that might grow global in scale. For a world already prone to planet-wide dust storms, the addition of alien debris could lock its skies into darkness for decades. Earth, by contrast, might see the event as a meteor storm of unknown chemistry, burning fragments leaving green trails across the heavens. Yet, for satellites and spacecraft, each shard would be a bullet moving faster than anything we can dodge. But beyond the physical dangers lies a deeper, more philosophical question. What is 3I Atlas? Is it merely an unusually fragile comet disintegrating in exaggerated fashion, or is it something else entirely, a phenomenon designed to multiply? In nature, replication is a trait of life. Viruses replicate, cells divide, species multiply to ensure survival. Rocks and ice do not, unless some hidden mechanism drives them to. Could 3 Atlas represent a kind of cosmic virus, a wanderer that spreads itself not by remaining whole, but by scattering? If so, then the swarm may not be a failure of structure, but the very purpose of its existence. This idea resonates with the ancient concept panspermia, that life travels between stars in the form of microscopic seeds hidden within comets and asteroids. If 3I Atlas carries complex organics or even the precursors to biology, then multiplication becomes not destruction but propagation. Each fragment is a seed hurled across space. Some will be lost, some will burn, but others may land intact, embedding themselves in soil, ice, or oceans. Over cosmic time, this mechanism could spread life through galaxies, not by singular vessels, but by swarms of alien stones. It is no wonder, then, that myths across the world speak of multiplying stars. Babylonian texts describe the torch that became many, raining fire upon the earth. Mayan codices show streams of glowing objects streaking from a single parent body, followed by records of famine and upheaval. Medieval monks wrote of the green star that gave birth to others, filling the skies with lights for months on end. Are these simply metaphors? Or could they be memories of past visitors like Three-Eye Atlas, multiplying as they crossed our skies, transforming one mystery into 1,000? Even within the scientific community, unease grows. If the fragments of Three-Eye Atlas are persisting, then they may remain active for far longer than expected. Ordinary comet fragments fade quickly because they lose their volatile material. But if this body is saturated throughout with exotic compounds, then each new break exposes fresh reserves, keeping the shards alive. That means the swarm will not diminish soon. It may grow larger with every fracture, expanding across the solar system like ripples from a stone tossed into water. This persistence also challenges the way astronomers track and classify interstellar visitors. Oumuamua, the first object of its kind, baffled scientists with its elongated shape and non-gravitational acceleration, but at least it remained a single body. Three-Eye Atlas, by contrast, is teaching us that interstellar wanderers may arrive not alone but as multiplying swarms. That realization could redefine how we think about galactic travel. Perhaps our solar system has already been crossed by countless such swarms, scattering fragments, dust, and chemistry without us noticing. Perhaps we are living in the after effects of a multiplication that occurred millions of years ago. If so, then Three-Eye Atlas is not just a visitor, it is a reminder that the cosmos is not neat, not predictable, not singular. It is messy, replicating, swarming, and sometimes it sends us mysteries that do not stay contained. Imagine the future unfolding. Astronomers detect new fragments daily, each one glowing, each one refusing to fade. Telescopes report sudden outbursts as smaller shards begin splitting further, creating even tinier bodies. The swarm grows dense, stretching across millions of kilometers. Some fragments plunge into the sun, triggering flares. Others pass near Mars, igniting storms. Still more drift toward Earth, seeding the skies with meteors. For weeks, months, perhaps even years, humanity watches the multiplication unfold. The skies themselves seem to teem with alien visitors, born from one. And through it all, the question deepens: is this breaking apart, or is it a deliberate swarm multiplying as intended? The distinction matters. If Three-Eye Atlas is merely disintegrating, then the danger will pass as its material disperses into space. But if it is multiplying in a way that sustains itself, then this may not be the end of a visitor. It may be the beginning of a new presence in our solar system. A swarm that lingers, fragments that persist, seeds that embed themselves on worlds. Not a fleeting comet, but a phenomenon that rewrites the meaning of interstellar visitor. And perhaps that is the real fear and wonder behind the mystery. For if Three Atlas is multiplying, then we are not watching something die. We are watching something spread, something from beyond our system, beyond our sun, beyond the limits of our knowledge, multiplying before our eyes. In that light, the question is no longer whether Three Atlas is breaking apart. The question is, what does it mean if the universe sends us swarms instead of singularities? And are we prepared to live in a cosmos where every visitor from the stars may come not as one, but as many? The fear of 1,000 shadows. Could Three Atlas fill the sky with debris? From the beginning, Three-Eye Atlas has defied expectations. What should have been a singular icy body drifting silently through the solar system has instead fractured again and again, spawning a growing swarm of fragments. Each break creates smaller bodies, each glowing faintly, each trailing dust and gas of its own. To astronomers, it now resembles less a lone wanderer and more a dissolving hive. And with each new fracture, one fear grows louder. What happens if these fragments scatter so widely, so chaotically, that the skies of Earth and Mars, and perhaps even the outer planets, become filled with drifting debris? Could Three-Eye Atlas create a nightmare scenario where 1,000 shadows haunt our skies for decades to come? The image is chilling. Countless fragments streaking across the heavens, some glowing as miniature comets, others lurking as dark, unlit bodies invisible until they strike. For Earth, the risk is not just beauty, but bombardment. A sky filled with debris means constant meteor activity, far beyond the fleeting showers we celebrate each year. Instead of a handful of meteors on summer nights, entire seasons could pass with daily fireballs, green streaks across the horizon, and shock waves rattling the air. Some would burn up harmlessly, but others, denser or larger, could explode in the atmosphere like the Tunguska event of 1908, flattening forests or shaking cities with thunderous blasts. And still others could reach the ground, embedding alien material into the soil. Mars, however, would bear the brunt. Positioned so close to 3 Atlas's projected path, the red planet is most vulnerable to a direct encounter with the swarm. Even fragments no larger than houses could gouge its surface with immense force, sending plumes of dust into the thin atmosphere. Enough impacts, and Mars could be plunged into a perpetual storm, its skies darkened for years. The fragile hopes of colonization would be buried under layers of dust and radiation, turning Mars into a stage for devastation rather than exploration. To future astronauts, a sky filled with debris would not inspire wonder. It would signal retreat. Yet the danger extends beyond individual impacts. A swarm of fragments would effectively create a new belt of debris within the solar system, a minefield humanity could not easily navigate. Satellites orbiting Earth would be under constant threat. The International Space Station, already vulnerable to micrometeoroids, would face a storm of alien bullets. Interplanetary spacecraft could be shredded en route to their destinations, their journeys cut short by shards invisible until too late. The infrastructure of space exploration, so vital to our future, could be crippled by a sky that no longer belongs to us, but to the remnants of 3 Atlas. The nightmare deepens when you consider the debris cloud's persistence. Ordinary comet fragments fade as their volatiles are spent, leaving inert rubble behind. But 3 Atlas's pieces seem different. They glow longer. They sustain their activity. It is as if each shard carries a reservoir of exotic material, keeping it alive long after it should have died. This means the swarm could remain bright and dangerous for years, even decades, rather than dispersing quickly. A sky filled with debris would not be a temporary phenomenon. It would be a new reality, a lingering shadow cast over every world in the inner solar system. For Earth civilizations, the psychological impact could be as profound as the physical. Imagine looking up night after night and seeing not a calm canvas of stars, but streaks of fire, constant meteors, fragments glowing faintly in clusters. The sense of stability, the assurance that the heavens are predictable, would be shattered. Ancient peoples once saw meteors as omens of doom, signs of war, famine, or the wrath of gods. How would modern humanity respond to skies that echo those ancient fears every single night? Panic, despair, even social unrest could follow, as people interpret the debris storm as apocalypse, prophecy fulfilled in green fire. And perhaps those prophecies were not exaggerations. Ancient texts from Babylon, China, and the Americas described the rain of stars and the torch that became 1,000. Mayan codices show streams of glowing objects splitting apart, filling the skies with fire. Medieval chroniclers spoke of nights when the heavens blazed with falling lights, so many that darkness was broken into 1,000 torches. These records, dismissed as exaggerations or misunderstood meteor showers, may instead be echoes of events like the one 3I Atlas threatens now. Perhaps interstellar visitors have filled the skies before, leaving terror and myth in their wake. Scientists face a different terror, unpredictability. A singular body can be tracked. Even a handful of fragments can be modeled. But 1,000? 10,000? Each fragment moves differently, pushed by gas jets, pulled by gravity, nudged by solar wind. The swarm becomes chaos, and chaos cannot be charted with certainty. Telescopes may catch some, but many will remain unseen until they arrive, flaring into meteors, exploding in the atmosphere, or colliding with spacecraft. A sky filled with debris means a sky beyond prediction, beyond control. And then comes the question of survival. Humanity depends on satellites for communication, weather forecasting, and navigation. If these are lost to collisions, society could stumble into darkness. Airplanes would lose GPS, ships would sail blind. Financial systems dependent on satellite time signals would falter. Power grids, already vulnerable to solar storms, would fail without spaceborne monitoring. The fear of 1,000 shadows is not only about falling meteors, it is about the collapse of the delicate systems that sustain modern life. Mars, too, would face collapse, though of a different kind. Colonists, if present, would find their habitats bombarded by dust and debris. Spacecraft on the surface could be damaged beyond repair. Greenhouses, solar panels, life support systems, all would be vulnerable. A dream of settlement could become a death trap, with colonists forced underground for survival, their hopes of expansion smothered under a storm of alien fragments. Yet not all possibilities are bleak. A sky filled with debris could also be a laboratory. Each fragment that enters Earth's atmosphere could be studied, its composition analyzed, its chemistry compared. If 3 Atlas carries exotic organics or even prebiotic molecules, then its debris might offer the first tangible evidence of life's seeds traveling between stars. The very fragments that terrify us could also reveal the building blocks of biology, supporting the theory of panspermia on a scale previously unimaginable. In destruction, there may also be discovery, but discovery would not erase the fear. Picture the scene. The night sky alive with constant streaks, auroras glowing from solar storms triggered by fragments plunging into the sun, power grids flickering, satellites failing. On Mars, dust storms rise as impacts scar the surface. On Earth, cities watch meteors fall in daily showers, some exploding with enough force to rattle windows. Humanity, for the first time in history, would live under skies crowded not with stars but with debris. The heavens would no longer inspire only wonder, they would warn. This is the heart of the fear of 1,000 shadows, that 3 Atlas, instead of passing quietly, will linger by multiplying, scattering, and filling the solar system with fragments that blot out certainty. Not one visitor, but 1,000. Not one path, but 1,000 trajectories. Not one mystery, but 1,000 unanswered questions streaking through the night. The universe often teaches by extremes. In 3 Atlas, it may be showing us that the line between beauty and terror is thin. A glowing interstellar comet becomes a swarm. A few fragments become a sky full of shadows. And in that transformation lies both wonder and fear. The possibility that we are witnessing not the breaking of a comet, but the reshaping of our skies for generations to come. From ember to inferno, could 3I Atlas awaken dormant solar storm cycles? For most of human history, the sun has appeared steady, reliable, and constant, an eternal ember that sustains life. But beneath that calm facade lies a volatile heart, a furnace of plasma woven with magnetic fields so complex that even the smallest imbalance can unleash storms of unimaginable power. Every 11 years, the sun's natural cycle intensifies these forces, creating peaks of activity marked by sunspots, flares, and coronal mass ejections. Yet astronomers know the sun is capable of more than this familiar rhythm. Throughout its long history, it has surged into phases of hyperactivity, episodes where storms are fiercer, more frequent, and more prolonged than normal. These dormant cycles, sleeping for centuries, may awaken again under the right conditions. And now, with the arrival of 3 Atlas, some scientists ask a haunting question. Could this alien visitor act as the spark that transforms the sun from ember to inferno? At first glance, the idea seems improbable. The sun is colossal. 1 million Earths could fit inside it, and its energy output dwarfs any external input. What could a fragmenting interstellar body possibly do to disturb such a titan? Yet history shows that even vast systems can be tipped into chaos by seemingly small nudges. Earthquakes erupt from subtle shifts in underground plates. Avalanches begin with a single falling rock. In much the same way, the sun's magnetic system, already tense during solar maximum, could be susceptible to an external trigger. If fragments of 3I Atlas plunge into the sun, they may not overwhelm it, but they could perturb localized regions just enough to ignite larger cascades of activity. The timing could not be more precarious. Our star is entering the peak of its current solar cycle, with sunspots multiplying and activity rising. This is when the sun is most restless, its fields twisted like coiled springs. An external injection of material, especially carbon-rich, nitrogen-heavy compounds from 3I Atlas, could destabilize these regions. The result may be a chain reaction of flares and plasma waves, not unlike dominoes falling across the solar surface. In this scenario, the sun does not explode or radically transform. Instead, it awakens into a prolonged storm era, an inferno of flares and mass ejections lasting years, perhaps decades. The consequences of such an awakening would ripple across the solar system. Earth, shielded by its magnetic field, would still be vulnerable to repeated impacts from solar storms. Satellites would fail under constant bombardment, communications would falter, and power grids would collapse more than once. Unlike the single Carrington event of 1859, which civilization recovered from, a storm cycle would mean wave after wave of disruptions, leaving little time to repair or prepare. Entire nations could stumble into blackout after blackout, supply chains would collapse, and economies could unravel under the weight of recurring chaos. Mars, with its weak magnetic shield, would suffer even more. Solar radiation would pour directly onto the surface, stripping away what remains of its thin atmosphere and leaving future colonists exposed to lethal levels of radiation. Dust storms, triggered by sudden heating, could engulf the planet for years, smothering any attempt to establish habitats or greenhouses. In this way, the inferno would not only stall humanity's dreams of expansion, it might erase them entirely. Even the outer planets would feel the effects. Jupiter and Saturn, with their powerful magnetospheres, might shield themselves, but their moons, Europa, Titan, and Enceladus, would be exposed to surges of radiation. Subsurface oceans, long thought to be cradles of potential alien life, might experience chemical changes as energetic particles bombard their icy shells. In this sense, the awakening of the sun would reshape not just Earth and Mars, but the very environments where life might be waiting to emerge. This possibility gains a strange resonance when compared to ancient traditions. Many cultures recorded memories of solar upheaval. Skies filled with auroras, seasons scorched by relentless heat, and sudden famines linked to burning suns. Babylonian texts describe eras when the heavens raged with fire. Mayan records tell of cycles where two suns seemed to burn together, one the familiar star and the other a torch from beyond. Medieval chronicles recount nights when auroras painted the skies for weeks, followed by summers of ruined crops. Could these accounts be echoes of dormant storm cycles, triggered by cosmic intrusions like 3 Atlas? If so, we may not be facing a new phenomenon at all, but the recurrence of a pattern humanity has forgotten. The scientific evidence for prolonged solar storm cycles is mounting. Ice core samples from Greenland and Antarctica show spikes of radioactive isotopes, such as carbon-14 and beryllium-10, linked to solar activity. These spikes suggest that in the past, the sun has produced bursts far stronger than anything in modern history, so-called Miyake events. These episodes, occurring roughly every 1,000 years, were not caused by human technology, yet their imprints are unmistakable in the geological record. If 3I Atlas arrives at just the wrong time, could it trigger another such event? Could it be the ember that turns dormant cycles into roaring infernos? What makes 3I Atlas particularly troubling is its fragmentation. A single object might graze the sun without lasting impact, but thousands of fragments increase the chances of repeated collisions or injections of volatile gas into the corona. Each impact may be minor, but together they could sustain instability. Instead of a one-time flare, the sun could be pushed into a feedback loop, with disturbances feeding disturbances until storm cycles stretch beyond their natural limits. In this way, the interstellar visitor does not destroy the sun. It awakens it, shifting its rhythms into a new, unpredictable gear. The technological impact on humanity would be catastrophic. Satellites knocked offline could not be replaced quickly enough. GPS would falter, grounding planes and disabling shipping. Power grids, constantly collapsing, could not be stabilized. Internet infrastructure, reliant on undersea cables and precise timing, would stumble into chaos. Hospitals, reliant on stable power, would struggle to operate. Even agriculture would falter, with global supply chains unable to transport food across nations. Humanity's reliance on electronics and orbital infrastructure has created a vulnerability no previous civilization has faced. A prolonged solar inferno would test our resilience to its breaking point. And yet, amid this fear lies a strange possibility. What if, by awakening dormant storm cycles, 3 Atlas also reveals truths about the sun we have never understood? What if, in studying its effects, we uncover the mechanics of superflares, the triggers of Miyake events, the secrets of plasma physics that could one day allow us to shield ourselves from such chaos? In destruction, there may also be discovery. Still, the imagery remains haunting. Imagine skies alive with auroras every night, shimmering across every latitude, their beauty masking the collapse of systems below. Cities darkened by blackouts, Mars shrouded in dust storms, probes around Jupiter and Saturn falling silent, And above it all, the sun itself, no longer the steady ember of millennia, but an inferno of storm after storm awakened by a visitor from beyond. This is the essence of the fear, that Three-Eye Atlas, by multiplying and fragmenting, will not only pass through our system, but leave it transformed. That a single spark from interstellar space could awaken cycles long dormant, shifting the sun from calm to chaos, from ember to inferno. Whether this will happen remains unknown. Perhaps the fragments will miss the sun entirely, dispersing harmlessly into space. Perhaps the cycles will remain as they have for millennia, unshaken by the visitor. But the uncertainty itself is enough to cast a shadow. For the first time, humanity watches a cosmic stranger not only with curiosity, but with the knowledge that its actions may ripple all the way to the heart of our star. And in that uncertainty lies the question we cannot yet answer. Is the sun steady enough to ignore the ember? Or will it flare into an inferno that changes everything we know about life under its light? Astronomers stunned. Why Three-Eye Atlas is brighter each time it breaks apart. When astronomers first fixed their telescopes on Three-Eye Atlas, they expected to see a faint, distant glow. Something similar to other comets, perhaps even less dramatic. Instead, the interstellar visitor immediately began defying expectations. It flared with sudden bursts of brightness, as though igniting from within. Then, when fractures appeared and pieces broke away, something stranger occurred. The fragments did not dim the parent body, as one would expect. Instead, Three-Eye Atlas grew brighter. Each time it broke apart, its glow intensified, as if disintegration were feeding its radiance. To seasoned observers, this was not merely unusual, it was astonishing. And now many are left asking, why does this mysterious wanderer blaze more fiercely the more it fractures? In normal cometary physics, fragmentation leads to fading. Comets are fragile, icy conglomerates of dust, gas, and rock. When they crack under solar heating, the smaller pieces quickly lose their volatile materials and die, leaving only inert rubble. The main body, weakened, grows fainter as its mass dwindles. Yet Three-Eye Atlas behaves differently. Every fracture exposes fresh surfaces, unleashing new jets of gas, producing sudden outbursts of green light. Instead of fading, it seems to rejuvenate, as though each wound opens a new source of energy. The result is an object that blazes brighter after breaking, its fragments glowing like embers in a cosmic fire. The key lies in its chemistry. Spectral analysis reveals an abundance of diatomic carbon responsible for the eerie green light that makes Three-Eye Atlas so distinctive. But beyond that, unusual ratios of carbon dioxide, nitrogen, and perhaps even exotic metals have been detected. These materials, trapped beneath the surface for eons in the cold of interstellar space, erupt violently when exposed to the sun's heat. Each fracture exposes deeper layers, rich with volatiles that vent explosively. It is as if every break tears off a mask, revealing a fresh source of fuel. In this sense, Three-Eye Atlas does not die with each fracture. It is reborn, brighter, more dramatic than before. The phenomenon has unsettled scientists for another reason: its scale. The brightening is not subtle. At times, Three-Eye Atlas has surged in brightness by factors of 10 or more, rivaling predictions and baffling models. Observers have described its outbursts as unnatural in intensity, too sudden and too extreme for ordinary cometary physics. Some even speculate that internal pressures, perhaps from trapped gases or exotic crystalline structures, are tearing the object apart from within, releasing not just ordinary energy, but something stranger. This has led to whispers of artificiality. Could Three-Eye Atlas be more than a natural body? Some have suggested it behaves like a self-destructing probe designed to scatter pieces that glow and signal. Each fragment, glowing like a flare, could serve as a beacon. While mainstream astronomers dismiss this as science fiction, they cannot ignore how the object breaks the rules of cometary behavior. Even among interstellar bodies, it is unique. The implications of its brightness are profound. A brighter body is easier to see, easier to track, but also more dangerous in its effects. Its glow is not just visual, it signals energy release, dust ejection, and volatile venting. Each flare means the surrounding region of space is filled with expanding material, capable of interfering with planetary atmospheres or solar winds. If the fragments drift toward Mars, their brightness is not just spectacle, it is threat. Clouds of dust could envelop the planet, while bursts of gas could interact with its thin atmosphere, triggering unknown chemical reactions. Earth too could be affected, though indirectly. If fragments intersect our orbit, their brightness may herald meteor storms unlike any in recorded history. Unlike ordinary meteors, which burn harmlessly, these fragments carry alien chemistry, glowing green as they streak through the skies. Their explosions in the atmosphere could produce strange colors, unusual compounds, or even seed the air with exotic molecules. Some might survive to the ground, embedding alien matter into our soil. The night sky could be transformed into a canvas of fire, beauty masking danger. What unsettles astronomers most is that the brightening shows no signs of stopping. With each fracture, they expected 3 Atlas to fade, yet instead it has surged again, as though the object is inexhaustible. If this trend continues, it may split into hundreds or thousands of glowing pieces, each contributing to a swarm of radiant fragments. The solar system could be filled not with one glowing visitor, but with a storm of them, an entire cloud of emerald fire drifting among the planets. Ancient records offer eerie parallels. Myths from Babylon, Mesoamerica, and medieval Europe describe the star that grew brighter the more it broke, or the torch that multiplied its light across the heavens. Some depict skies filled with green fire, as though a single body had shattered into many, each burning brightly. Could these be memories of past interstellar visitors, behaving like 3 Atlas does now? If so, then humanity may have seen this spectacle before, and remembered it only as omen, disaster, or divine warning. But if the brightening is a natural process, it still leaves puzzles. Why is 3I Atlas so volatile compared to other comets? Some researchers suggest it may have formed in a colder region of another star system, preserving compounds too unstable to survive in ours. Others argue its elongated shape and fractured structure indicate a body already weakened before it entered our solar system, perhaps battered in collisions with other interstellar debris. Its brightening may be a sign not of vitality, but of imminent collapse. In this interpretation, each flare is the death cry of a dying body, glowing brighter as it burns itself out. Yet others see in its brightness a kind of message from the universe. If interstellar objects like 3I Atlas carry the building blocks of life, then their brightening may be part of a cosmic strategy to spread material far and wide by breaking apart, scattering glowing fragments across systems, seeding planets with chemistry. In this sense, the light of 3I Atlas is not destruction. It is creation, the radiant sign of life's seeds being sown. Still, the spectacle carries danger. 3I Atlas continues to fracture, each break flaring brighter, until a swarm of glowing shards fills the sky. Mars is bombarded with fragments, its atmosphere thick with dust. Earth watches as meteor storms of green light blaze nightly, some exploding with devastating force. Satellites fall silent, power grids falter, and cities stare skyward at the alien fire. Astronomers, their predictions shattered, scramble to understand what they are seeing. The universe, it seems, is reminding us how little we truly know. This is why the brightening of 3I Atlas shocks astronomers so deeply. It is not just that it grows brighter, it is that it grows brighter when it should be fading, that it defies every expectation, that it turns destruction into radiance. In this inversion lies the mystery. Is it breaking apart or multiplying into lights? Is it dying or reproducing? Is it a comet or something stranger, carrying rules of chemistry we have not yet encountered? For now, the answer remains hidden in the emerald glow of the object itself. Each flare is a signal, each fracture a revelation. But the meaning of those revelations remains beyond our grasp. All we can do is watch, stunned, as 3 Atlas grows brighter each time it breaks, a cosmic paradox blazing across the night. Perhaps in its glow lies a warning, or perhaps in its glow lies a gift. Either way, it is a reminder that the universe is far from silent, and sometimes it speaks in fire. The fractured visitor. What if 3I Atlas splits beyond control? When astronomers first spotted 3I Atlas, it was described as a solitary visitor, an elongated green glowing body slipping into our solar system from the deep interstellar dark. For weeks, it was treated as an individual, an oddity but still a singular object. Yet, as telescopes followed its progress, the illusion of unity dissolved. The visitor fractured, large pieces broke off, smaller shards followed. Instead of fading into obscurity, these fragments glowed, active and volatile, behaving less like dying rubble and more like miniature copies of the parent body. Each split made the situation more complicated. Each fracture multiplied the unknowns. And now, a grim question looms. What happens if 3 Atlas does not stop? What if it splits beyond control, scattering into tens of thousands of fragments, filling the solar system with unpredictable debris? The first concern is practical: predictability. A singular body, no matter how alien, can be charted. Its orbit can be modeled, its path projected years into the future. But once an object begins to fracture, those calculations collapse. Every shard follows a slightly different trajectory, nudged by solar radiation, twisted by jets of outgassing gas, tugged by the faint pull of nearby planets. Each new fragment adds to the chaos. With hundreds, the system becomes nearly impossible to track. With thousands, prediction breaks down entirely. The fractured visitor ceases to be a single traveler. It becomes a swarm. And swarms cannot be modeled with precision. For Mars, which lies disturbingly close to the projected path of 3 Atlas, this is especially dire. If the visitor continues to fracture unchecked, even a fraction of the swarm could intersect the Martian orbit. Each fragment, no matter how small, carries destructive potential. A house-sized shard impacting the Martian surface could release energy equivalent to an explosion. 100 such fragments spread over days or weeks could blanket the planet with dust storms lasting for decades. Colonization efforts would collapse before they began. Mars would become a world under siege, not by its own nature, but by an interstellar intruder scattering itself across its skies. Earth, though further away, would not be immune. A fragmented swarm increases the chances that at least some shards will drift toward our orbit. At first, this might mean spectacular meteor storms, night skies ablaze with green trails, fragments burning up as they enter the atmosphere. But with enough numbers, probability begins to weigh against us. Some fragments would survive entry. Some would explode in the atmosphere, like the Tunguska event of 1908, which flattened thousands of square kilometers of Siberian forest. Others might strike the ground, leaving craters and spreading alien dust into the biosphere. The fractured visitor splitting beyond control would not merely be a scientific curiosity, it would be a planetary hazard. But there is another layer of fear, deeper and more disquieting: persistence. Ordinary comet fragments die quickly. Once split, they lose their volatiles, fade, and vanish into darkness. Yet 3I Atlas has proven different. Its shards remain bright. They glow with the same green fire as the parent body, as though each carries reservoirs of exotic chemistry waiting to be released. This means that if it splits into thousands of pieces, each one may remain active for years, decades, even centuries. Instead of dissipating, the swarm could linger, creating a new population of alien objects in the solar system, foreign bodies that will orbit, collide, and interact with our worlds long after the parent has passed. Imagine a future where every planet, every moon, every spacecraft must contend with fragments of 3I Atlas. A sky once predictable becomes a minefield. Satellites around Earth are constantly under threat from incoming debris. Space stations and lunar bases are forced into shielding orbits. Probes en route to the outer planets vanish as they are struck by unseen shards. Even interplanetary travel, the dream of humanity's future, is jeopardized. A fractured visitor, unchecked, could hinder our steps into space for generations. Ancient traditions echo this fear in haunting ways. Babylonian records speak of a star that became dust without end, filling the skies with falling fire. Mayan texts depict the serpent that split into many, raining destruction for years. Medieval chroniclers describe nights when the heavens rained torches without ceasing, followed by famine and upheaval. Were these exaggerations, or could they be memories of past interstellar visitors that split beyond control, seeding skies with endless debris? If so, then 3 Atlas may not be unique. It may simply be the latest chapter in a recurring cosmic cycle humanity has forgotten. The scientific implications are profound. If interstellar bodies regularly fracture into swarms, then our solar system may have been seeded countless times in its history. Each swarm could deliver exotic chemistry to multiple worlds at once. Some fragments may burn in atmospheres, releasing molecules that interact with local conditions. Others may land intact, embedding themselves in soils, ice, or oceans. In this way, a fractured visitor becomes not only a hazard, but also a vehicle of panspermia, the spread of life's building blocks between stars. 3I Atlas splitting beyond control could mean devastation for some planets and genesis for others. Yet even if such a process carries seeds of creation, its immediate consequences could be catastrophic. Consider the chain reaction of fragments falling into the sun. One piece plunges into the corona, releasing carbon and dust, destabilizing magnetic fields. A flare erupts, another follows, and another, until the sun itself storms without pause. The fractured swarm becomes not only a debris field, but also a trigger for solar chaos. Earth, Mars, and the outer planets would all be swept by waves of radiation, their skies painted with auroras, their power grids faltering under the assault. From one fractured visitor could come not only falling fire, but a storming sun. Astronomers now face the challenge of vigilance. Each telescope sweep reveals new shards, each one glowing, each one defying the expectation of fading. What began as a singular mystery has become an expanding puzzle, one that grows more complex with every observation. Scientists cannot say when the fracturing will stop, if it will stop, and so they are left to watch, to model chaos with imperfect equations, to wonder if they are witnessing a disintegration or a transformation into something stranger. What unnerves many is that 3 Atlas seems to multiply faster than it loses material. Each fracture should weaken it, but instead it appears to rejuvenate. Brightness surges, activity intensifies. It is as though breaking apart is not a sign of failure, but of function. Could this mean that 3I Atlas was never meant to remain whole? That its true nature is to split, to scatter, to spread? If so, then the fractured visitor may not be an accident of cosmic fragility, but a deliberate process, a survival strategy written in its very structure. Imagine the unfolding future. The parent body finally shatters completely, leaving no singular object, only thousands of fragments drifting together. The swarm spreads, some falling into the sun, some striking Mars, some drifting into Earth's path, some lost to the outer planets. For years, perhaps centuries, the solar system remains haunted by these shards. Every meteor storm, every aurora, every satellite failure is traced back to the day the visitor fractured beyond control. Humanity, living under skies littered with alien debris, learns to adapt, but never escapes the memory of the visitor that multiplied instead of dying. This is the essence of the fear, that 3I Atlas is not breaking in the way we expect. It is not ending. It is not fading. It is transforming into something else, something harder to define, harder to predict, and harder to survive. A fractured visitor that may never truly leave because it has scattered itself across the system in fragments without end. The question, then, is not whether 3I Atlas will split. It already has. The question is whether it will stop or whether we are watching a process that will scatter 1,000 shadows across our skies, reshaping the solar system in ways we cannot yet imagine. If it splits beyond control, the visitor will not pass quietly into the night. It will remain in fragments, in meteors, in storms, in legends, an interstellar puzzle that refuses to die because it has chosen instead to multiply. Chain reaction in the cosmos. Could splinters of 3I Atlas collide with Mars and bounce back to the sun? The trajectory of 3I Atlas has already stirred fear and wonder. A glowing interstellar wanderer, its path threads perilously close to Mars, leaving scientists anxious about what might happen if fragments of the fractured visitor intersect with the red planet's orbit. But what truly unsettles astronomers isn't just the possibility of impact, it is what might follow. Could splinters of 3I Atlas collide with Mars, unleash devastation across its surface, and then through gravitational slingshot be redirected toward the sun itself? This chain reaction, improbable as it sounds, may not be impossible. And if it occurs, the consequences would ripple across the solar system, transforming one planetary encounter into a stellar disturbance. To understand the scenario, one must first grasp Mars's precarious position. The red planet, smaller than Earth and with a weaker gravitational hold, lies almost directly in the projected path of 3I Atlas. While Earth's strong gravity often captures or repels incoming bodies, Mars is more vulnerable. It cannot deflect much, but it can redirect fragments with slingshot effects. When a fragment passes close to the planet, its orbit can be altered dramatically, sending it hurtling on new trajectories, some outward into the asteroid belt, others inward toward the sun. With 3I Atlas breaking into countless shards, The odds of at least some being caught in this gravitational shuffle increase with every fracture. Now imagine a splinter striking Mars itself. Depending on its size, the impact could gouge vast craters, raise dust storms, and scatter ejecta far beyond the planet's surface. On Earth, meteor impacts sometimes hurl debris into orbit, some of which even escapes the planet's gravity entirely. Mars, with its weaker gravity, is even more prone to such outcomes. A sufficiently violent collision could loft chunks of Martian soil, along with pieces of the impacting fragment, into space. These could then be nudged by the sun's pull, curving back inward until they spiral toward the solar furnace. The result, material from Mars and from an interstellar body fused in collision, plunging together into the sun. At first glance, this may seem like an exotic but harmless spectacle. After all, the sun consumes far larger bodies without notice. Yet context matters. If 3I Atlas is already destabilizing solar cycles with its volatile chemistry, the addition of Mars-forged debris could act as a multiplier. It would not be one fragment entering the corona, but many in waves, some carrying the unique chemistry of an alien visitor mingled with Martian dust. In the already unstable atmosphere of the sun, such injections could trigger localized eruptions, feeding the domino effect of solar storms. A planetary collision, instead of ending at Mars, might bounce chaos back to the heart of the system. The implications for Mars itself are sobering. Impacts from 3I Atlas fragments could devastate its fragile environment. A swarm of small splinters might ignite global dust storms lasting for years, choking the skies in red haze. Larger impacts could vaporize water ice, releasing plumes of vapor that freeze again as snow, altering climate cycles. For colonists, real or hypothetical, the surface would become uninhabitable, forcing retreat into underground shelters. But the chain reaction does not stop there. Every impact would also send ejecta outward. Mars would not only be a victim of bombardment, it would become a source of new projectiles, scattering fragments back into the system. Astronomers worry most about timing. The sun is already in a volatile phase, nearing the peak of its 11-year cycle of magnetic activity. Each flare and coronal mass ejection hints at underlying instability. If fragments from Mars's impacts are redirected inward during this period, they could arrive at the worst possible time, when the star is primed to erupt. Just as one falling rock can trigger an avalanche, a stream of debris plunging into the solar corona could unleash storms far beyond their apparent scale. What began as a fragment striking Mars could end as a solar inferno engulfing Earth with radiation. The imagery is apocalyptic. One moment, telescopes record impacts lighting up Mars's surface. The next, ejecta arcs outward, glowing faintly as it curves back toward the sun. Days later, the sun erupts in flares, plasma storms blasting across the void. On Earth, auroras ripple across the skies, power grids collapse, satellites fall silent. Humanity, already anxious from watching the visitor fracture, would realize it is now part of a chain reaction spanning planet and star. The fractured visitor is no longer a curiosity. It has become an active agent in reshaping the solar system's dynamics. History offers eerie foreshadowing of such scenarios. Ancient records speak of stars feeding on the dust of planets, of skies darkened after rains of fire, followed by solar upheaval. Babylonian tablets describe omens where a torch struck Mars, followed by the sun burning hotter than before. Mayan glyphs depict serpent-like trails descending onto planets, then curving back toward the sun. Medieval chronicles tell of nights when the heavens fell twice, first as falling fire, then as storming light from the sun itself. Could these be mythic memories of past chain reactions, where interstellar fragments struck planets and then rebounded into the star? If so, then 3I Atlas may not be the first fractured visitor to ignite such cosmic dominoes. From a scientific perspective, the possibility raises fascinating questions. If Martian ejecta, fused with interstellar material, were to fall into the sun, it could create a natural experiment unlike any before. Astronomers might glimpse how alien chemistry interacts with stellar plasma, revealing new processes that textbooks have never imagined. Could such injections trigger spectral emissions unique to interstellar matter? Could they reveal clues about the building blocks of other star systems? For all the terror of a chain reaction, it could also open doors to discovery. Yet the risks cannot be understated. Earth has endured solar storms before, but only singular ones. A chain of eruptions sustained by waves of debris would be unprecedented in the age of satellites, electronics, and global dependence on space-based systems. Power grids would fail repeatedly, aircraft would be grounded, GPS would collapse, and communication networks would falter. In this light, the chain reaction is not simply a cosmic curiosity. It is a threat to civilization's infrastructure, a reminder that we live under the fragile grace of a star that can be disturbed by visitors from beyond. Imagine the long arc of such a sequence. Fragments of 3I Atlas strike Mars, blasting dust and debris skyward. Some pieces arc outward, vanishing into the asteroid belt, while others curve inward. Weeks later, they plunge into the sun, triggering a wave of flares. Earth reels under auroras, satellites die, and power grids flicker. Then more debris follows, each new impact fueling further eruptions. For months or even years, the sun storms, fed by material that originated in an interstellar body and was redirected by a planet's weak gravity. The fractured visitor, by breaking apart, has created a cycle of chaos that neither fades quickly nor spares any world in its path. This is the fear behind the chain reaction, that the visitor will not pass quietly, that its splinters, instead of dispersing harmlessly, will strike Mars, rebound toward the sun, and ignite storms that reverberate across the system. It is a vision of interconnectedness, of cosmic forces linked in fragile balance, disrupted by one wandering body. In the end, the question is not whether such a chain reaction is certain, it is whether it is possible. And possibility in the vastness of space is often enough to warrant fear. For now, astronomers watch, track, and model, their equations chasing shards they can barely see. But beneath the calculations lies unease. That one fractured visitor could set off a sequence of collisions and eruptions that reshapes not only a planet, but the star that sustains us all. The fractured visitor is not simply a guest, it is a catalyst, and if its splinters strike Mars and bounce back into the sun, it may remind us that in the cosmos, nothing exists in isolation. One fragment can alter a planet, one planet can alter a star, and one visitor from the deep can awaken storms that echo across the solar system for generations. A new solar era? Scientists warn of what 3I Atlas could unleash. The history of our sun is written in cycles, 11-year magnetic rhythms, longer phases of calm and storm, and rare, violent surges that leave traces in the ice of Earth and the rock of ancient forests. Humanity has lived under these patterns, usually oblivious to their deeper significance, taking for granted the steadiness of the light that rises each morning. But with the arrival of 3I Atlas, that complacency is being shaken. This fractured, unpredictable visitor from interstellar space is forcing scientists to ask an unsettling question. Could its passage mark the beginning of a new solar era? The warning signs lie in the object's strange behavior. Instead of fading as it sheds material, 3I Atlas has grown brighter with each fracture, its fragments acting as smaller comets that glow green with exotic chemistry. These shards are not inert, they are active, volatile, and potentially numerous beyond counting. Each fragment is a hazard on its own, but together they may form a swarm capable of interacting with planets, atmospheres, and even the sun itself. And that possibility, the chance that interstellar fragments could act as catalysts for solar instability, is what drives the warnings of astronomers around the world. If the sun is nudged into hyperactivity, the consequences could be transformative. Scientists already know that our star is capable of far more than it shows in ordinary cycles. Evidence of Miyake events, massive spikes in solar radiation recorded in tree rings and ice cores, suggests that the sun sometimes erupts with storms hundreds of times stronger than any witnessed in modern history. These events are rare, but they are not impossible. If 3I Atlas, by breaking into swarms and plunging fragments into the corona, acts as a trigger, then the sun could be jolted into such a phase again. A solar maximum could turn into something far greater, a storm era lasting decades, defined by flares, plasma ejections, and radiation storms that shake the entire solar system. On Earth, this would be more than an inconvenience. Our entire civilization depends on fragile technology vulnerable to solar activity. Satellites, the backbone of communication, weather forecasting, navigation, and defense, would be among the first casualties. Power grids, already known to be susceptible to geomagnetic surges, could collapse on continental scales. A single storm might plunge regions into darkness for weeks. But an era of storms, wave after wave of disruptions, would be catastrophic. Recovery would not be possible before the next impact. Economies would buckle, food distribution chains would break, and global infrastructure would falter under the weight of constant solar assault. Humanity, more dependent on technology than ever before, could find itself thrown into a struggle for survival. For Mars, the situation could be even bleaker. With its thin atmosphere and weak magnetic field, the red planet is already vulnerable to solar radiation. A new solar era marked by violent storms could strip away what remains of its air, sterilize its surface with radiation, and trigger dust storms of unimaginable scale. Colonization efforts would be delayed, perhaps for centuries. Future astronauts might find themselves forced underground, cut off from the dream of building cities beneath alien skies. For a world that has long symbolized human expansion, a solar inferno could turn it into a wasteland too hostile for life or settlement. The outer planets would not escape either. Jupiter and Saturn, with their strong magnetospheres, would absorb much of the radiation, but their moons, Europa, Titan, and Enceladus, would be bathed in storms that could alter their icy surfaces. Subsurface oceans, long speculated to harbor the ingredients for life, could be chemically altered by energetic bombardments. The promise of alien biology might not vanish, but it would be reshaped, its potential futures redirected by forces unleashed from the sun. Yet the warnings extend beyond practical danger. They touch on deeper, more existential fears. If 3I Atlas can awaken a new solar era, it means that stars are not isolated entities, evolving only according to their own internal processes. It means they can be nudged, disturbed, even provoked by encounters with bodies from interstellar space. In that case, the cosmos may be far less stable than we imagine. Stars across the galaxy may its storm eras triggered not just by their natural cycles, but by the passage of fractured visitors scattering debris into their coronas. Life, fragile as it is, would be constantly at the mercy of wanderers that arrive without warning, rewriting stellar behavior in their wake. Ancient myths may reflect dim memories of such upheavals. Cultures from Babylon to the Maya recorded visions of two suns burning in the sky, of green torches heralding storms, of times when the heavens themselves seemed to rage. Medieval chronicles tell of years when auroras painted the skies nightly, followed by famine, war, and social collapse. Could these be the echoes of past solar storm eras, triggered by visitors like 3I Atlas? If so, then humanity has lived through shadows of this before, barely, and without the technological dependence that makes us so vulnerable today. What makes the current warnings urgent is the scale of unpredictability. No one knows how many fragments 3I Atlas will produce, where they will go, or what chemistry they will unleash when they interact with the sun. It could pass without incident, a spectacle of green light and fire fading into memory. Or it could scatter enough material to jolt the sun into fury. The difference between those outcomes is impossible to calculate with certainty. That uncertainty is what drives the cautious but stark warnings. Prepare for the possibility of disruption, because the fractured visitor may yet do more than dazzle. It may awaken. The vision of a new solar era is terrifying, but it is also profound. Imagine Earth bathed in auroras every night, skies glowing red and green at all latitudes. Imagine satellites failing one after another while engineers struggle to shield new launches. Imagine cities plunged into blackout, then flickering back only to fall again with the next storm. Humanity would be forced to adapt, to rediscover resilience in the face of celestial forces it cannot control. And yet, amid the hardship, there might also be awe. For never before has humanity witnessed its star in such raw fury. Never before has it been reminded so vividly of its dependence on the sun's grace. The fractured visitor has become more than an object in the sky. It has become a mirror, reflecting our vulnerabilities, our myths, our scientific limits, and our fears of what lies ahead. Whether or not it unleashes a new solar era, its arrival has already changed the way we see the sun. No longer simply an ember, no longer simply predictable. It is a furnace that may awaken without warning, stirred by forces from beyond. Perhaps 3I Atlas will pass, fading into the dark, leaving only the memory of green light and broken fragments. Perhaps the sun will remain steady, its cycles unchanged. But the warnings will linger, because the possibility has been raised. The cosmos is not closed, it is not orderly. It is a web of interactions, fragile and vast, where even a single visitor can alter the rhythms of a star. This is what scientists mean when they speak of a new solar era. Not prophecy, not certainty, but possibility. The possibility that 3I Atlas, by multiplying, fragmenting, and scattering itself across our system, could ignite storms that transform not only our skies, but our future. It may not be the first to do so, it will not be the last, but it reminds us of a truth we have long forgotten. Our star is not immune to the cosmos. It listens, it responds, and sometimes it awakens. One visitor becomes thousands. The fear of 3I Atlas multiplying across space. When 3I Atlas first entered the solar system, it appeared as one elongated, glowing visitor from the interstellar deep. It was already strange, its green aura, its unpredictable brightening, its trajectory that defied simple models. But then came the fractures. Chunks of its body tore free, drifting in formation like shadowy satellites. And rather than fade, each fragment glowed with activity, venting volatile gases as if alive. Suddenly, astronomers realized they were not watching one visitor, but many. And with every new fracture, the fear deepens. What if 3I Atlas multiplies endlessly, transforming from a single mystery into thousands, scattering across space, unstoppable and unpredictable? The prospect of multiplication is more than poetic, it is perilous. A single interstellar object can be studied, tracked, even dismissed if its path is safe. But thousands? Each fragment follows its own trajectory, nudged by outgassing, warped by solar winds, and tugged by planetary gravity. Some may be flung outward, vanishing into the outer system. Others may fall inward, curving toward the sun or crossing the paths of Earth and Mars. With thousands of bodies, probability shifts. What was once unlikely, the chance of impact, collision, or solar disturbance, becomes inevitable. In this way, multiplication magnifies risk not linearly, but exponentially. Consider Mars, lying squarely in 3I Atlas's projected corridor. A single intact body might have passed by without incident, but a swarm is another matter. Even a handful of fragments could rain down on the red planet, gouging craters, lofting dust into its fragile atmosphere, and triggering planet-wide storms. With thousands, the bombardment could last for years, transforming Mars into a scarred wasteland of fresh impact sites and choking skies. Colonization plans, already tenuous, would collapse under the weight of a hostile environment made worse by alien debris. For humanity, Mars would cease to be a frontier of hope. It would become a reminder of how quickly one visitor can multiply into calamity. Earth, too, would face consequences. Our strong magnetic field provides protection, but it cannot defend against direct impacts. A sky filled with multiplying fragments means meteor storms far beyond the beauty of the Perseids or Leonids. Night after night, green trails would streak the heavens, some exploding in the atmosphere with Tunguska-like force, others reaching the ground. Satellites in orbit would become targets in a shooting gallery, vulnerable to collisions at speeds faster than bullets. Space stations, lunar missions, even spacecraft traveling to the outer planets would risk obliteration by unseen shards. Multiplication, in this sense, is not only a scientific puzzle, but a direct challenge to humanity's expansion into space. Yet the danger of multiplication extends further, into the realm of the sun. Each fragment that plunges toward the corona could act as a spark, destabilizing magnetic knots and triggering flares. A single object might pass unnoticed, but thousands could drip-feed disturbances into the solar atmosphere, sustaining storm cycles far longer than natural rhythms allow. The fractured visitor, by multiplying, could turn the sun into a storming giant, hurling plasma across the system for decades. Earth's power grids would fail repeatedly. Mars's surface would be sterilized by radiation. The outer planets would suffer storms that reshape their moons. One visitor would become thousands, and those thousands could alter the star that sustains us all. The most unsettling element of 3I Atlas's multiplication is persistence. Fragments of ordinary comets fade quickly, their activity spent after brief exposure to sunlight. But these shards appear different. They remain bright. They vent gases. They glow with the same spectral green as the parent body. This suggests that each fragment contains reserves of exotic chemistry capable of sustaining activity for years. If so, then multiplication is not a temporary spectacle. It is a process that could seed the solar system with long-lived swarms of alien bodies, orbiting for centuries. Humanity could live under skies haunted not by one visitor, but by its countless children. Ancient traditions may already echo this fear. Babylonian records describe a torch that split into many, filling the skies with falling stars. Mayan codices depict serpent-like trails fragmenting into streams of fire. Medieval chronicles recount nights when the heavens burned with 1,000 torches, followed by famine and unrest. Were these exaggerations of meteor showers or distant memories of past interstellar visitors that multiplied across space? If so, then 3i Atlas is not unprecedented. It is simply the latest iteration of a cosmic pattern humanity has long forgotten. From a scientific perspective, the multiplication mystery raises profound questions. Is 3i Atlas fragile, its structure prone to collapse, or is it designed by nature or something more deliberate to replicate itself? In biology, replication ensures survival. Viruses multiply, cells divide, species reproduce to spread their genetic code. Could an interstellar object carry a similar principle, scattering itself into many so that at least some fragments endure? If so, then 3i Atlas may not be dying as it breaks apart. It may be fulfilling its purpose. Each fragment is not a loss, but a legacy. This idea ties directly to the theory of panspermia, the notion that life spreads between stars via comets and asteroids. If 3i Atlas carries organic molecules or prebiotic chemistry, then its multiplication becomes a mechanism of distribution. Thousands of fragments mean thousands of opportunities to deliver those compounds to planets, moons, or even the sun itself. Some will burn, others will embed, but a few may seed the conditions for life. In this sense, the fractured visitor may be more than a hazard. It may be a gardener, scattering seeds across the solar system in a way no singular body could. Yet for humanity living now, the awe of such speculation is tempered by fear. Imagine the night sky transformed, not into the calm order of stars, but into a storm of fragments. Auroras shimmer nightly, satellites vanish, power grids collapse, and every mission beyond Earth faces peril. Mars, once a dream of colonies, becomes a wasteland under constant bombardment. The sun, stirred into chaos, storms for decades. Civilization itself trembles under the weight of a visitor that refused to remain one, choosing instead to become many. This is why scientists warn so urgently. The multiplication of 3i Atlas is not just a curiosity, it is a threat multiplier. Each fragment increases the odds of disaster. Each glow in the telescope adds another variable to an already chaotic equation. The fractured visitor, once dismissed as a comet-like wanderer, has become a swarm in the making. And if that swarm grows beyond control, the solar system may face a new reality. One visitor becomes thousands, and those thousands alter the skies for generations. The ultimate question is whether multiplication is a process that will fade, or a phenomenon that will continue until nothing remains of the original body. If the fragments disperse harmlessly, humanity may breathe a sigh of relief. But if they persist, if they grow in number, if they seed storms, collisions, and chaos, then the 3i Atlas will not be remembered as a visitor at all. It will be remembered as a transformation. The moment the skies multiplied, the moment one became many. The moment humanity realized the cosmos does not always send us singular puzzles. Sometimes it sends us swarms. In that possibility lies both wonder and terror. Wonder that the universe may use multiplication as a way of scattering chemistry and potential life. Terror that our fragile world is caught in the path of a visitor that refuses to fade, choosing instead to fill our skies with countless shadows. And in those shadows, humanity sees its vulnerability, not just to one object, but to the many that may follow in its wake.